UC Santa Cruz 2024 Compost Engineering Challenge. Our goal is to create a system for home composting that is usable for home gardeners, that is DIY, that is cheap and easy to build, and also rat-proof. We've launched this challenge because we ultimately want to keep more food and food scraps from going into landfills where they produce methane, which is a contributor to climate change. We also want to encourage people to turn their food scraps into beautiful soil. You can't grow homegrown tomatoes without beautiful, wonderful compost. So why are we sending this very precious, wonderful resource that is food scraps over to some company which then is going to sell it back to you? Instead, we want to encourage people to recycle it on site with a home composting system. But that home composting system has to be cheap, it has to be DIY, and it has to be rat-proof. So we have a group of amazing, talented students who are participating in this challenge, and they're going to explain their designs to you.
So here is my finished vermicompost model. It's pretty small. It's 4 5-gallon buckets stacked on top of each other. The top 3 5-gallon buckets have holes drilled into the bottom of them. And the bottom bucket does not have any holes, but it has a spigot, a 3/4 inch spigot installed. And so what you will do in this system is add bedding material, and that would be shredded cardboard, moistened shredded cardboard, leaves, grass, other carbonaceous material to the top 3 layers. That's bedding. And then you would add ground up food waste to the top layer periodically, maybe once a week, whenever it accumulates in your home, to feed the worms. And the worms will travel up through the bin to eat the food waste at the top, and then their worm castings will be forced down to the bottom. They don't want to live in their poop. And that's what you want to collect as a vermicomposter, is the worm castings. An additional byproduct of the system is leachate, and that is the liquid that comes from the food or from any rain that falls into your system, and it goes to the bottom. By opening the spigot or just by leaving it open with a container underneath, you'll collect the leachate, and that could be diluted and used as another source of fertility for your plants in addition to the worm castings. When the second to bottom bucket is full, there's 2 here and there's 2 down here. When this bucket is full of worm castings, empty it and put it back on top and start over. Always keep the lid on the top of your system to keep the rain out, to keep out any pests, flies, rats, also to keep the moisture in and to keep your system from drying out, because that's an important aspect of the vermicompost system, is that worms need to be able to breathe through their skin and have the right level of moisture. So happy vermicomposting.
This is a system that's designed to feed the worms in your garden bed directly, and also I tried to make it to be as convenient as possible, so once the compost is finished you can just dump it out into the garden bed. You don't have to haul compost around. This box could be designed any size that you want. The important thing is it has to be all enmeshed in this wire so that the rats don't get in, so it does need this hard mesh. And then this lid comes off and you can put your scraps and your browns directly in here and compost in place. You would need a couple of these across your garden beds because once this fills up you'll probably need some more volume. One important note is that this is not going to get hot. It's not a hot compost, so you can't put things that have pathogens like meat or eggs or like dairy. You don't want to get E. coli or salmonella. It's not going to kill off those pathogens. But otherwise, this is one of the systems that we're testing for the Compost Engineering Challenge.
Alright, so this is how a continuous flow vermicomposter works. Basically, we have a large box, and inside of this box we have a mixture of compost, soil, coffee grounds, and shredded paper. The shredded paper will help absorb excess moisture, the coffee grounds help with odor and also with pest control, and then the compost and soil provide a microbe environment that the worms can feed on, and also for the microbes to feed on the green waste, which we add into the top. So this green waste we're going to take and we're going to add in an even layer at the top, over top all of our compost, soil, coffee grounds, and shredded paper. And our worms will go into that soil and they'll dig down to about 15 inches deep. Now we make our soil about 20 inches deep because we don't want our worms to fall out the bottom of our box, because our box actually has a false bottom, and that's because we're going to harvest our vermicompost out of the bottom. So the bottom of this box actually looks like this. It's basically a frame with slats that allow openings so that when we come to harvest our vermicompost, which takes about 6 months for vermicompost to form, we'll take a trowel or any kind of tool and we can scrape in between these slats to get out our vermicompost. And any worms that end up in there, we'll just throw back into the top.
This is the home biogas 2 system that we wanted to test in this compost challenge, but ultimately we decided not to test it this year for a couple of reasons. One, it's very large and probably larger than what people want for a home scale system. It requires a tremendous amount of water, and when we built it, we discovered a leak here that we couldn't fix. The water was leaking out, so we couldn't actually use it. The concept is interesting. We'd love students to do a DIY version in the future, maybe a cheaper version. This is very expensive, but for now, we're calling it quits on this system.